Good afternoon, everyone. Good morning to anybody that's here from Chicago as well, because it's only 3:30. It's been great so far, right? This conference has been really great. What have you learned so far? Three things, right? Either you're going to learn AI or become complacent. AI will make you complacent eventually, and we need to bring AI to India, right? And this is something that's actually very, very important in the context of strategy. So where I spend most of my time is working at the intersection of strategy and technology. And for the past few years, I've been spending time defining and trying to solve for a very, very specific paradox. And that paradox is at the intersection of these two disciplines, strategy and technology. So that paradox is, how will strategy change as a result of the monumental advancements in analytics? Any answers in the room? No? Become more data-driven, right? Strategy will become more data-driven. This is something that's actually very, very important. I've spent the last few years in boardrooms, in corporate war rooms, and in classrooms defining this problem and trying to solve for it. But if we take a step back, we need to understand what strategy really is. And we also need to understand what analytics really is. Because before we can solve this very convoluted equation that you see up there, we need to define these terms. So I'll give you the definition of strategy, so you don't have to worry about that since that's not this conference. Strategy is just intelligence-driven decision-making, right? Write that down somewhere. Strategy is intelligence-driven decision-making. But the question then becomes, what is analytics? Because we hear so many different versions of that term, right? Predictive analytics, machine learning, artificial intelligence. Are those even considered analytics? Because whenever I talk to students, whenever I talk to executives, it seems like these concepts are removed from one another. So they say we're doing analytics and we're also doing machine learning. We're doing analytics and we're also doing artificial intelligence. But is that true that these are two different things? Because a lot of companies have set up their organizations that way. So they have a chief analytics officer, a chief AI officer, and then a chief information officer. Most companies are set up this way today. And those roles, those first two roles, chief analytics officer and chief AI officer, only emerged since 2011. So we're talking about 7 years. And that AI part, probably the past 3 years. So what's going on exactly? I want you to tell me the answer for that. So if you could take out a pen and paper, or your phones are fine. We're going to keep this very interactive. I want you to imagine a world without analytics. Just write down one or two characteristics of that world. A world without analytics. What does that world look like? A dream? We were just in that dream a few years ago. So it's a dream. Do everything yourself. Emotional. Inconvenient. Chaos. Shooting in the dark. Subjective. I'm sorry? Not identifying the right goal? Okay. So now I want you to imagine a world with analytics, but I do want you to write this down. What is the impact of analytics? So we're moving from a world that is subjective, a world that is emotional. Are we now in a world that is not emotional? Are we in a world where all the goals are defined? Because we are living in the age of analytics and analytics on steroids, as this conference is evidence of. Whenever we're talking about analytics, it doesn't matter what kind of analytics. There's three components. Or is there? So there's input, there's the modeling, and then there's output. Those are the only three components to all types of analytics. And if that is the litmus test, then artificial intelligence, machine learning, robotics, all that applies here, right? Even fields that are somewhat far away removed from analytics, like IoT, for instance, because that's just the input stage. Did I miss anything? No? But what about business problem formulation, which is the most important piece of analytics? Because you can have the fanciest technology, you can build the most elegant model, but it's worthless. It's useless because it doesn't solve for a business problem. And when I say a business problem, it could be something that is in the for-profit sector or in the non-for-profit sector, right? That's a business problem. And that's where we always have to start. But there's a problem here. Number one is that whenever we're building analytics, that's not where we're starting. Right? What were the 3 things you learned from the conference? Either learn AI, ML, or become complacent. So we're starting with the modeling. We're not starting with the business problem. And this is what's going on in the United States, right? I spend a lot of time looking at different startups for investments on the private equity side, and most of them, the majority of them, start off by talking about their modeling skills. They start talking about the technology and how this technology is transformative. But what business problem are you solving? And that's something that's very important. And that's the title of the talk today, Ambidextrously Ambivalent Analytics. Quite a mouthful. And most people will not know what it means, just like they don't know what analytics mean, because they're starting off with the modeling. If every time somebody's talking about analytics, they're starting off with AI, ML, then they're just talking about modeling. They're not talking about analytics. And that's something that's very important to start talking about in our teams, in our companies, with our investors, whenever we are building analytics, because it makes them ambidextrously ambivalent, meaning they solve only one problem, and it's the technology problem. But analytics have to solve the business problem, and then the technology problem. And that's something that's very important. So we define a business problem. Based on the business problem, we choose a data set or multiple data sets. And based on that data set, we either go out and get more data, and then we choose the right modeling approach, right? And then from there, we go to output and visualization and storytelling, which I teach in the University of Chicago in conjunction with the Jigsaw group. But this is still ambidextrously ambivalent analytics, because you're still only solving one problem. As a matter of fact, you're solving one problem, but you're causing another problem on the other end, because this is a simplification of a model. This is a simplification of one model or one piece of analytics in a firm. Now, when I asked you about the definition of analytics, we said that it's data-driven decision-making, or it enables data-driven decision-making. How many decisions do you think a firm makes on a daily basis? Hundreds. How many decisions do you make on a daily basis? Hundreds? 35,000. Each and every one of you, from the time that you open up your eyes till the time you close your eyes to go to bed, you make 35,000 decisions. Right? Getting up in the morning, just opening your eyes when you wake up, that's a decision. There's actually a model that's embedded, right, by habit that just fell into your subconscious. What about a firm? An average Fortune 500 company makes about 10 million decisions a day. And this is a publicly traded company, meaning they are very careful about what they publish and what decisions they make. Imagine firms that are owned by private equity shops or employee-owned firms, how many decisions they make on a daily basis. So this is a simplification. There are thousands, if not tens of thousands of these sitting in firms. And if the models are not talking to one another, they are still ambidextrously ambivalent. Because one decision is being made on one side of this firm, where we were talking about risk management earlier, and the risk side, and this risk model is not talking to the finance model. So the risk team is making intelligent decisions, or data-driven decisions, and the finance team is making data-driven decisions, but chances are they were looking at two different data sets, two different modeling approaches, looking at clients in completely different ways, and that's a problem. So, let's talk about ambidextrously intelligent analytics. Ambidextrously meaning you can write with both hands. That's what ambidextrous means. You can write with both hands. And if the analytics can solve the technological and stated business problem, and also solve the strategy problem of the firm, it becomes ambidextrously intelligent. So what we want to do is essentially give you a framework to take back to your companies, to take back to your schools, right, to your education on how to use analytics, and really structure the thinking and the implementation and the execution of analytics to not just solve one business problem and cause 10 on the other side of the house, but solve one business problem and also contribute to solving the strategy problem of your organizations. So here's an analytics roadmap. The analytics roadmap starts off with the historical analytics and ends off with intelligence analytics. Historical analytics is largely what was happening in 1950 all the way up till 1990s. Right? In 1950, Mattel is the Barbie doll designer. They were doing analytics. They were doing it on pen and paper. They were calculating which segment to target their marketing towards. And they would do that in conjunction with fashion designers. So a little girl would go and buy a Barbie doll that had a specific designer bag on it. And they targeted a specific demographic. And that specific demographic was said, or they, based on their analytics and calculations, was going to grow up into certain jobs. So they were going to the fashion designers and telling them, partner with us right now, so in 20, 30 years, when they're executives, they can buy your products. So before all the computing power, before the access to big data, cloud computing, machine learning, artificial intelligence, robotics, people were actually ambidextrously intelligent, meaning solving for the strategy problem as well. But the reason they were doing that is because they were not overly relying on models. When I was at Oliver Wyman doing consulting, and Oliver Wyman built most of the risk models for most financial services firms in the US. Anybody that works in a US firm would know that. We had a phrase that most people turn on the models and turn off their brains. And that's what all this computing power gives us false comfort with. But even when people were doing historical analytics, they were not turning off their brain. They were using models, they were using analytics, but they kept their brain on. The problem with historical analytics is what we did not mention here, which is the biggest missing component we didn't talk about is assumptions and limitations. I spend maybe 70% of my classes talking to students about assumptions and limitations. I spend a good 50% whenever I'm looking at models on the business side, looking at the assumptions that went into the models. And assumptions are very important. So whenever they were building historical analytics, it meant that they looked at a specific data set. So they were looking at a specific data set, and they made an assumption. And the assumption was that the future was going to behave like the past. And in most cases, as you know from statistics, regression to the mean, right, things will eventually even out at the mean. But how long will it take? And that's the problem that we ran into in the '08 crisis, is that we thought that the future was going to behave like the past, right, on the financial services side. And it didn't. And that's the problem with historical analytics, is that we're making that blanket assumption. Then we move to predictive analytics. Predictive analytics are the analytics that are built on historical data sets, but we change the assumptions, right? Within your firms, this would be called expert judgment or overlaying the model, right? So we have a historical data set, understanding of the assumptions of the historical data set, and then from there, we overlay the model with new assumptions. But those new assumptions come from the business unit, not from analytics. And that's why they're called expert judgment. But the problem with that approach is that it's subjective, right? So it takes us to the world before analytics. When I asked you about a world before analytics, the answer was it's subjective. Then you move into real time. Real-time analytics uses that same framework, except it constantly uploads live data sets. So the assumptions are continuously being uploaded and updated. But it's still in the present. So it doesn't tell me what decisions are going to be made in the future. From there, we have preventative. And a lot of people wrongfully believe that predictive is a higher analytics than preventative. And that's not true. Because preventative analytics are the risk analytics, are the finance analytics, are the analytics that are used in healthcare. Because they're preventative. They're stopping something that could go wrong from happening. And they're all built on both historical data sets, real-time data sets, and then expert judgment. But you see how the expert judgment comes at the end? Not right after historical data sets. After real-time, then you put the expert judgment. From there, you move to the personalized analytics. We were going to run a workshop for executives in the C-suite on analytics, and they came back and said, well, we're really interested in analytics, it's interesting, but why don't you come talk to us about digitalization? Well, what is digitalization? It's analytics, right? Digitalization is analytics. It's either the output of analytics, right, the visualizations that you were talking about earlier, or the input. And that's what personalized analytics are. But that's a problem as well, because we keep using terms that we don't know what they mean, because they're advertised a specific way. And that leads us to false comfort as well. So personalized analytics. Personalized for the individual use. But more importantly, and what makes it more powerful, is that it gathers data at the individual level. Remember at the beginning of the talk, I told you the definition of strategy? What was the definition of strategy? Intelligence-driven decision-making, right? The most important concept in strategy is segmentation, right? I have to segment my clients, right? And even in analytics, it's very, very important to do your segmentation, right? That's where segmentation really comes to fruition. That's where it becomes really strong, because I'm gathering data at the individual level. So as I progress through this analytics roadmap, I start to become more ambidextrously intelligent. From there, we talk about participatory and intelligence analytics. And that's just another way of saying machine learning and artificial intelligence. But that comes at the tail end of analytics, and having mastered all these different disciplines before that. The most important thing about this slide, the most important nugget that you need to take away, the most important nugget you need to take away from this conference is not what's the latest and greatest technology, is not what is everybody else doing from a technology perspective, but rather, where is my firm today? Because most people that work in analytics, and unfortunately even executives, don't understand where their firms are starting. And that's a problem. That's a talent and organizational issue. And that's why you see a chief analytics officer from one firm go to another firm, stay there for a couple months, maybe a year, maybe 2 years, and then leave somewhere else. And then the firm is left clueless. And that executive is left clueless about what they did do and what they didn't do. And that's also a problem. So then we have intelligence, right, which is the promised land. I'm not sure what the promised land is referred to in India, but in the United States it would be like Jerusalem, right? That would be the promised land. So I'm not sure what but that's the promised land. That's what most people are talking about. But they neglect everything else here. Or they think that they can buy their way out of these different steps. But you have to learn to crawl before you can walk. You have to learn to walk before you can fly. So we have to take these orchestrated steps with the understanding that we're trying to get to ambidextrously intelligent analytics. There are three main aspects of, or three main levers that you need to work on in order to get to ambidextrously intelligent analytics. The first one is data analytics, which we've talked about, understanding where I am on the roadmap and where I want to go. What are the requirements to get there? The next thing is talent. And the last thing is strategic orientation. On the talent side, there's 4 types of talent. There's talent that's delivery driven. What is the deliverable? That's what I'm going to work on. In one of the big energy firms that I worked with, there was an analyst building demand models. And I asked him about the line of business that he's working in, and a specific question about a product. And he had no clue what products they were selling. He just knew they were an oil and gas company. And that's where the delivery-driven folks are. They are providing baseline value in a real-time driven analytics world. If you have delivery-driven talent in a predictive or historical analytic world, you're losing to competitors, or you're at value destruction. Because these individuals that are powering your analytics, so to speak, aren't taking in consideration what the business assumptions are. Because when you're coming up with these analytics, you have to think about not just the data input assumptions and the modeling assumptions and the output assumptions, but the business assumptions in order to choose the right modeling approach, in order to choose the right analytics to use. From there, you have offering-driven talent. These are people that have a fundamental understanding of the business or fundamental understanding of the products and services that you sell. But they are not compensated based on the products. They're not compensated based on the business units. They're only compensated to get you from point A to point B in a specific product. And then you have product-driven talent. This is talent that's compensated for both the technological angle as well as the product. So they work on analytics, but they're also thinking about innovation. They're also thinking about how can we innovate as a business unit? How can we innovate on the product side? How can we be the leader in our field or industry? And then last but not least is the business-driven talent. And these are the ambidextrously intelligent individuals because they speak the language of analytics and they also speak the language of the business. A lot of times within organizations, as you probably know, you have folks that are building analytics and their first language is math, second language is programming. And then you have somebody that's their manager that's just translating from the business to analytics, from analytics to business. And that's a problem. So that's where you're getting the highest value. You're creating new demand for the product, right? Because the people that are powering these analytics, regardless of where you are on the roadmap, they understand the business, meaning they understand the client, they understand the strategy, and they're moving you forward on all angles. So, if I took responsibility to master and apply an ambidextrously intelligent analytics strategy, I could just sit down and write 1 or 2 sentence endings after this and really think about where your firm is in terms of the roadmap, where you want to go, and what levers you need to pull.